In this tutorial you learn how to drive a stepper motor with the Arduino Uno. But before we start, we will have a quick look at a conventional DC motor. Such DC motors are very useful since they are easy to use. Just connect plus and minus and you are ready to go. However, one disadvantage of these motors is that you have only very little control over the rotation position. For example, it is very hard to move the shaft by just 10 degrees. Stepper motors overcome this problem, as they divide a full revolution into multiple steps, and they can be driven step by step. This is such a stepper motor, the 28BYJ48. When you buy a 28BYJ48, it often comes with a ULN2003A driver board. As you can see by looking at a number of wires, wiring and driving a stepper motor is a bit more difficult than driving a DC motor. For these reasons, these driver boards come in very handy. Today I want to show you how we can use an Arduino and this driver board to control the 28BYJ48 stepper motor. One important remark: the theory and mechanics of stepper motors are not that easy to understand. For example, there are unipolar and bipolar steppers, two-phase and multi-phase steppers, wave drive, half-step drive and full-step drive methods, and so on and so on. If you have a different stepper motor, the wiring and the program can be different. Here I have another stepper motor which has, for example, 6 wires compared to the 5 wires that we have here. Therefore, please keep in mind that this tutorial will focus just on the 28BYJ48 motor. Nevertheless, the wiring and source code could be of use for similar motors. Okay, let's start with the wiring. Wiring the stepper motor to the driver board is very easy, since the motor's connector fits perfectly here. Next, we connect the driver board's input pins to the Arduino. We need to connect 4 pins. In this tutorial, I make use of the Arduino's digital pins 8, 9, 10 and 11. 8 is connected to in 1. 9 is connected to in 2. 10 is connected to in 3. And 11 is connected to in 4. Lastly, we have to provide a power supply for the driver board. Since my setup will not consume too much power, I draw the current directly from the Arduino Uno. To do so, I connect one of the Arduino's ground pins to the driver board's ground pin, and a 5V pin to the driver board's VCC pin. Please keep in mind, the current that you can draw from the Arduino is limited. If you draw too much current, you might end up damaging your Arduino. As a rule of thumb, you can draw about 400 mA out of your Arduino's 5V pin. If you need more milliamps or you are not sure about your power consumption, then use an external power supply. The next step will be to write a code and transfer it to the Arduino. Thankfully, the Arduino platform has already a stepper library, which makes our life a bit easier. The stepper library is not the best choice when it comes to efficiency and richness of features, but it will be sufficient for our purpose. The stepper library needs the motor's number of steps per revolution. Usually, you can find this number in the datasheet. Since we are driving the motor in full step mode, we have to set 2038 here. Next, we initialize the stepper with the following parameters: number of steps and then the digital pins 8, 10, 9, 11 that we used for connecting the Arduino to the driver board. In the loop function we set a speed to 1 revolution per minute. Then we call the step method, which triggers the motor to do 2038 steps. If you did the math, you already know that a stepper will do one full revolution in about 1 minute. Then we add a delay of 1 second. Next we do almost the same thing again. This time we set the speed to 6 revolutions per minute, so we are 6 times faster than before. Lastly, we call the step method and set a number of steps to minus 2038. As a result, the motor will do a full revolution again, but this time in the other direction. As we set the speed to 6 revolutions per minute, the motor will need only 10 seconds for the full revolution. Okay, let's try it out. I will set a timer in order to track whether our program works correctly. With each loop function call, the motor will start turning 2 times. The first turn should take about 1 minute and the second turn should take about 10 seconds. Okay, so our program seems to work correctly. Thanks for watching and goodbye.